In this video, we will learn about electromagnets. So, an electromagnet is that which is easily magnetized on passing a current through a solenoid and easily demagnetized on switching off the current, such as we have learned about soft iron, right? Now, an electromagnet may be made up of any shape, but following two shape electromagnets are very common. The first one is the I-shape electromagnet. So to prepare an I-shaped electromagnet, we take a solenoid coil of thin insulated copper wires. So this is the solenoid now, and we place a soft iron bar as a core inside the solenoid. So this is the soft iron bar inside the solenoid. Now when the current is passed through the solenoid, then the iron bar is magnetized. So the magnetization of soft iron bar lasts so long as the current is flowing through the solenoid coil. So if the current flowing in the solenoid coil is switched off, the iron bar immediately loses its magnetism. Okay. The second one is the U-shaped electromagnet. So to prepare a U-shaped electromagnet, we take a U-shaped iron core and two solenoid coils of insulated thin copper wire are wound on the two arms of the iron core like this. Now, however, the winding of the two arms as seen from the end must be in opposite sense, which means that if one is north, other should be south. Now, the two coils are joined together, and when the current is passed through the solenoid coils, so you can see the two coils are joined. When the current is passed through the solenoid like this, then the electric current in coil of arm 1, that is this arm, is flowing in clockwise direction, but in second arm, that is this arm, the current is flowing in anti-clockwise direction. So as a result, one end of U-shaped iron core, the end of arm 1, develops the polarity south pole and the other will develop as north pole. Okay. Now, as soon as the current is switched off, the iron core loses its magnetism. Now, the magnetic strength. So, the strength of the electromagnet can easily be increased by increasing the solenoid current. Moreover, the polarity of electromagnet may also be reversed by reversing the direction of current flow through the solenoid. Now, what are the uses of electromagnet? So, electromagnets are used in electric bells, telephone receivers, microphones, electric relays, and various electronic devices such as radio set, television, CRO, etc. Giant sized electromagnets are used in cranes for lifting heavy machineries and bulk quantities of iron and steel. Electromagnets are also used to produce very strong magnetic fields in cyclotron and in MRI machines. Okay. Now, what is the difference between an electromagnet and a permanent magnet? So, an electromagnet is soft iron, but a permanent magnet usually is steel. Secondly, the magnetic strength is quite large and can easily be controlled by controlling the current flowing through the solenoid. But the magnetic strength is not very strong and cannot be controlled. Thirdly, the magnetization lasts as long as electric current is flowing through the coil in case of electromagnet. But in case of permanent magnet, magnetization is a permanent phenomenon in nature. Now, the polarity of electromagnet can easily be reversed by reversing the direction of current flown in the coil, but the polarity of a magnet cannot be reversed. I hope this topic is clear to you. Thank you.